So don't forget our hybrid functions is really just an exercise on a little bit of graph sketching over specific domains. Yeah. So in this case, let's start with the first one. We're going to sketch the graph of negative x plus 3 over the specific domain of x is less than or equal to 0. So negative x plus 3, so it's got a negative gradient of 1. We've got a y-intercept of positive 3. And we've got a negative gradient. Yeah. So I'm going to go through 3 and the gradient looks a little bit like that. Yeah. So if I was to sketch it all the way through, I'd carry all the way down, but I only want to sketch where my graph is less than or equal to 0. So maybe that will do there. I probably made sure my gradient was exactly right, but it's not crucial. Although maybe it should be. Let's make sure. So if I pick another point, if I say put x equal to negative 2, I get negative 2, which is 2, plus 3 is 5. So at the point negative 2, 5. So it should go through that point there. So then I can be actually, you know, I've got a good axis there. I've got a good scale. So maybe I should aim to be hey, what's happened there, as accurate as I can. Having said that, it's now taking me forever to get it right. Y-intercept of 3, and it's going through 5, so that looks about right. Yeah, and continuing arrow, solid dot. So there's that line there. What about the next one? The next one, we're going to sketch the graph of 2x plus 3 between 0 and 2. So we know they're straight lines, so we can probably just plot our endpoints. At x equal to 0, 2x plus 3 is equal to 3. So we're joining up at that point. Technically, we're going to have a hollow dot in blue, but it joins my solid green dot. And then at x equal to 2, I get 2 times 2 is 4 plus 3 is 7. So the 0.27, so the 0.27 is about there. Hollow dot, just in case, we don't know whether they'll join up. And we can just put our line in pretty close. Yeah, so there's the second graph. Finally, we'll go yellow. Negative 2x plus 3. Again, let's put well, it starts at 3 actually, so it's a gap, isn't it? So at x equal to 3, y is equal to negative 6 plus 3, which is 7. So at negative 3, we get 7, so it's there, and it's solid dot. Negative gradient. I might just pick a point, so if I put x equal to 4, x equal to 4, y equal negative 8 plus 13. What's that? 5. So it goes through the 0.45, which is about there. So it just gives me an idea of the slope of the line that I need to draw. So I'll get my ruler back, wherever it is. There it is there. And both of these are solid. Oh, well, the top one's a solid dot and the other one's continuing, isn't it? So it goes down like that. So it was important we had a hollow dot on that second point, wasn't it? So let's just, oh, that's not bad. Let's just make it a nice hollow dot. All right, so there's the graph of that, that composite function. So we've spoken a little bit about domain and range. So we can see that, well, what is the domain? Everything except for that gap there, isn't it? So it's, I'm sort of more of a fan of putting the domain is from minus infinity to 3 not inclusive union, 2 not inclusive, union 3 inclusive to positive infinity. Yeah. My range, well, as disjointed as it all is, my range is still going to be R. Yeah, because the green line goes up to positive infinity, the yellow line goes down to negative infinity. All right, so look, I think they're a great exercise, the hybrid functions, because they get you to, they get you a good exercise on graphing our basic functions over specific domains.